Hello guys, I hope everybody is able to see me, hear me and see the screen properly. Can I get a quick confirmation on chat? सबको मेरी आवाज clearly सुनाई दे रही है क्या? Can I get a quick confirmation on chat? Perfect. Perfect. Okay, so we're going to be talking about today the second part, or basically the second book of your FRM preparation. Okay, we are talking about the quantitative analysis book, and I'm going to try to do the first part of the book. Again, the focus is on looking at important concepts. I'll give you a brief about what is that there in the important concept in the chapter and how they would ideally try to test you. Okay, so let us start with the first chapter, which is the fundamentals of probability. Now, generally, what I have seen in the last 2 to 3 exams, okay, please note this chapter and your there's one more chapter, multivariate random variable. Okay, both of these chapters are kind of connected. So they will ask you roughly around 3 questions. Okay, one question is going to be very, very easy, but the other 2 questions are going to be difficult. Okay, so if you find any question related to direct applications of fundamental probability of multivariate random variable, be cautious. Okay, if you feel that the question is not it's slightly tough, you'll find it slightly tough, do not waste time, do it at the end. Okay, so on an average, try to avoid these questions at the start, the fundamentals of probability and your multivariate random variable. Now, what is this chapter primarily talking about? Conditional probability, then unconditional probability. Okay, so we have been, if you've already seen the content, okay, so ideally what should happen in the conditional probability that we talk about is this. Say for example, okay, I'm saying I would be able to go to office early, okay, or I will be able to go to office late. Okay, if I am able to go to office early, I will be able to leave early or leave late. Okay, leave early or leave late. Okay, so there can be a tree diagram probability situation like this. Now, suppose if I'm saying that 70% chance that I'm going to reach office early, if I reach early, there is 80% chance that I'll also leave early, 20% chance that I will leave late. Similarly, over here, 70% chance and 30% chance. Now, one thing that is very, very clear when we talk about conditional probability, okay, these numbers are changing. So your probability of coming early depends upon what is the previous situation. Okay, whether you have reached office early or whether you have reached office late. So your probabilities are changing. That is why it is called as conditional probability. So in the tree, okay, this is your unconditional probability. Okay, this is your conditional probability, all of these. Okay, and this, when you multiply both of them, you get the joint probability. I am assuming everybody is aware about this. Okay, so joint probability in this case, suppose we are talking about joint probability of leaving early and going to office, leaving early and going to office also early. That is nothing but your 70% and 80%, which is nothing but 70% into 80%. That number, okay, will represents your joint probability. Okay, so for the exam, okay, you should be clear what is unconditional, what is conditional probability. That understanding has to be very clear. Okay, joint probability also, what does the joint probability means? Both event A and both event B are happening simultaneously. Okay, event and event space is generally not very important. Okay, event space is nothing but combination of all the outcomes that can happen with the particular event. Okay, so for example, when I'm flipping a coin, I know it is going to be head or it is going to be tail. There's only two outcomes that can come. So basically all the outcome, okay, when you combine together, it becomes a event space. Okay, independent and mutually exclusive event. Okay, so independent events, if you remember, I'll just walk you through the formulas. Okay, so the mutually exclusive events are like these. You can just have a quick read over here. Mutually exclusive event, the formulas. Okay, now over here, this part, the last part, probability of A and B, that is a joint probability. So when you have mutually exclusive events, so you have events like this, A and B, they are mutually exclusive events. So there is nothing common in between. So what will happen? You will take the entire A plus entire B, the minus the common part. This part is always going to be 0. This last part will always be 0. But when we talk about events which are not mutually exclusive, that means they have something in common. So this is A, this common part is this. Okay, so what you will have to do when you take probability of A plus probability of B, you're actually double counting this. Okay, you're actually double counting. So you have to minus probability of A intersection B. A intersection B means the joint probability. Okay, that you will have to minus. So the two formulas are almost same. The only difference is that when it's mutually exclusive, the last part is 0, and it is not mutually exclusive, there is some common part, there is some positive value to it. So in the exam, very unlikely that they might test you what is mutually exclusive, what is non-mutually exclusive. That is very difficult to test. What they might test you is the second rule, which is the AND rule, which is joint probability. So if I go forward, this is basically the PPT that I run in class for the students. So 1 second, I missed. This is my independent event and dependent event. Okay. So independent event means you have probabilities which is not getting impacted by anything that is happening previous. Okay. So in the exam, very high chances that they might ask you a question on dependent event. Okay. So they will give you a situation and they will ask you to find the probability. Okay. So when you calculate your joint probability, what is the broader formula? Okay. Oops. 1 second. I made a mistake. Yes. So when we talk about the joint probability, okay, so joint probability is nothing but you have unconditional probability, okay, into your conditional probability. Okay, you basically multiply both of them and then you get the joint probability. Okay, so this joint probability is also written as A intersection B, and this is what they might ask you in the exam if they want to ask you. Okay, this section you should remember. Okay, when you talk about independent event does not have any interaction. So both the events are independent. That means there's nothing common in between. Okay, so there's nothing impacting in between. So effectively probability of A into probability of B will come. Okay, also this part A slash B, what is the slash? Given A given B. So B has already happened. Now we are talking about what is going to be the probability of A. Now if the events are independent, then the A given B is also going to be probability of A, which means the conditional probability is also equal to your unconditional probability. Okay, which can indirectly tells you that the relationship is independent. If it is not equal, so if I go back to that same example, okay, I had actually deleted that, but if we go back to the same example now, so you are going to office late, you are going to office early, you are leaving late, leaving early. So leaving late and leaving early. Okay, so this probability, which is your conditional probability, which is this conditional probability and conditional, this probability will be different depending upon what has happened in the past. Okay, so that is something you should remember, or you should be able to understand or pick it up. Okay, two mutually exclusive event, more or less easy, simple. This kind of exam questions might come, very unlikely, but might come. Conditionally independent event, which basically means on the face they look independent, not very heavily tested in the exam. Okay, so don't take the pressure as such. But what they are trying to highlight is, to understand this example, you have to understand the example. Okay, so this example you can read before the exam. So suppose you're scoring above average on the exam. This is one event. The B event is you're taller than the average. Now, because somebody is taller, there is higher chances that he is more in age and he has more brain and he's going to score more than the average. So there is some, even though these events look like independent, but they are not. They have some conditional independence. What is conditional independence? If you are taller, the condition is this: if you are taller than the average, then automatically the score is going to be better than the average. Okay, so they might look independent, but they are not, because a taller student is going to be older and hence he will be able to perform better. That conditional independence. Okay, if the height is lesser than the average, okay, then it is independent. But if the height is bigger than the average, then it is not independent. That is why the name is conditional independence. Okay, I hope everybody is with me. So discrete random variable, not very test. These are easy examples. Huh? They don't test you on this. Mostly they are going to be testing you on Bayes theorem. Okay, conditional, unconditional, they have explained the concept. Okay, this formula, okay, it is nothing but your basic formula, probability of A, B, which is a joint probability. Okay, we can write it as probability of A into probability of B given A. What I can do is I can take this down, I can take this A down and I can find this conditional probability. So Bayes' theorem is nothing but you're trying to find a conditional probability. Okay, so what is this conditional probability? Probability of B given A, okay, is nothing but the joint probability, both of them happening, B and A both happening together, okay, and the denominator is whatever has already happened, that is this A, probability of A. So you always have to think it this way. If somebody is facing a problem in remembering the formula for Bayes' theorem, it is very simple. Okay, suppose I'm saying probability of D slash E. Okay, so first numerator is going to be joint probability of both D and E happening together. So DE, and whatever is after this slash, that means it has already happened, that will come in the denominator. You have to remember it that way. Okay, so when I go towards this, so this is the Bayes' theorem formula. Okay, and you might have to use a probability matrix, and from that matrix you're going to be calculating the answer. Okay, so one of the examples of probability matrix is I'll show it to you. For example, this. Okay, so if suppose we are saying interest rate will increase, decrease, economy is going to be good, normal, or poor. If somebody asks me, okay, that okay, can you find the probability of economy being good given, okay, given the interest rate has increased, so what I am supposed to do is numerator is going to be joint probability of both economy good and interest rate increasing, that is this 14%, okay, and the denominator is going to be this interest rate increasing. Now over here I need an unconditional probability, which is nothing but the addition of all the interest rate increasing. This number is yes 40%. So interest rate increasing, just add all the joint probabilities and you'll be able to get the answer. Similarly, if somebody asks me what is the probability of interest rate going down, okay, given your economy is poor. Okay, so first of all you need a joint probability of both things happening together, economy being poor and interest rate going down, which is this 24%, so that becomes your numerator, and then you need an unconditional probability of economy being poor, which is this 30%. So that is the final answer. That is the way you calculate the answer. Okay, I hope everybody is with me. You can also post your queries. We'll try to address the query also as soon as possible. So Paras, answering to your query, please explain that event 2 happening together given the other event has already occurred. I think so you're talking about the joint probability, no? Already it has happened. You will have to frame the question properly. I'm not very clear. Okay, so going back, so Bayes' theorem is something which you should remember, and I've given you the application also of how to find it. Okay, if there is a probability matrix, you can utilize it to get the answer. So this kind of question, short question might be there. If I want to make it slightly difficult, I will give you a probability matrix, and on the basis of that I will ask you to solve. Okay, on the basis of that I will ask you to solve. So Bayes' theorem is important. Again, these two examples are similar related to Bayes' theorem, so obviously focus on that. Very, very basic. Moving towards the next chapter. Paras, I will have to look at the question to answer your query. I might not be able to pick it up through this live session. You can reach us on WhatsApp and I'll address it. Okay. The next chapter is random variable. Now there are specific sections in that chapter which can get tested. Okay, and when I'm doing all of these sessions, okay, I'm mostly focusing on how they might ask you a question. Okay. Dimple, answering to your query, Bayes' rule is conditional independence variable? No. Bayes' rule is nothing but trying to find the answer or the probability of a conditional thing. For example, conditional event. Okay, the conditional independent variable that you're talking about, that's a separate thing. Okay, that's a separate thing. Let us go to the random variable. So over here they are giving you the basic bifurcation. What is a discrete random variable? What is a continuous random variable? Okay, so mostly if they want to test you, they will test you this. They will give you some probability mass function formula and they will ask you to calculate the probability. Okay, so if you look at this, they're talking about Bernoulli random variable. Bernoulli random variable will only take two values. And look at the formula: p raised to x raised to 1 minus p raised to 1 minus x, all of that. Okay. Now this formula is a PMF, probability mass function. Why probability mass function? Because these are your discrete random variable. Discrete random variables will take the outcome which you can count. Continuous random variable, basically you cannot count, you have to measure. Okay, because any value it can take. Even if you give two values, say 5 and 6, there are infinite numbers between that, and that is what is continuous random variable. So when you want to calculate a weight, okay, the weight can be 36 kg, 36.789 kg. Okay, but when you want to basically calculate the say number of students in the class, so that is a discrete number. It can be 3 or it can be 4. It cannot be 3.5. Okay, so you can count the outcome. That is the broader thing. So probability mass function can get tested. Okay, this one, expectation, important. So they might ask you a question, a theory plus some calculation question, where they are asking you to calculate the expected value. Okay, and this is the base. Once you are clear on this, the variance and all becomes very easy. That is the reason. They will ask you a question more theoretical base. Okay, so it's going to be a combination of some calculation with more theory. Okay, so E is the expectation operator. You have to be very clear on that. How do they calculate the expectation? That also needs to be clear. Okay, the concept that when you calculate expectation, you actually don't get that number in real life. So what is the expectation when you're rolling a die? 3.5. But when you roll a die, you actually don't get 3.5. So that also should be clear, that when I'm going to keep on rolling die for a long period of time, then my answer is going to be closer to that average. Okay, answering to the query, Nikhil, in exam, do we expect more of theory question on quant? Yes. So my understanding, okay, obviously the paper is going to be very different for each of you, but my understanding is that out of 20 questions, 12 to 13, 14 questions will be theory. So you expect more theory question from the quant book, okay, because it's more of statistics, and in statistics you should know what is happening, okay, what is the idea or how they're running the model, rather than asking you to calculate. Because when you go and work in the bank, they have everything inbuilt, so you don't have to worry about the calculation. You just have to worry about what is the output and how do I interpret it. Okay, so I hope everybody is clear till this point. So this is very basic, expectation and all. This question, like I said, in combination of theory. I hope everybody is with me. If there is a query, please put it on the chat. Huh? Now you can remember these two things, which is nothing but if you, I'll just give a brief gist about it. So if I have the formula, okay, so suppose if I have a variable x, I hope everybody is able to see that. Okay, variable x. Now I've taken some numbers, random numbers, huh? And I'm also assuming that the probability is same for all of them. Okay, if there's a random variable x and I've created one more random variable which is z. Now this z is nothing but it is taking the value of x but adding 3. So there is a constant which is getting added. So how do I do this? Check. So what is the first number? 390. So I've taken 393 because I'm adding 3. Similarly, the next one, 285 plus 3. Okay, so basically my variable z is nothing but 3 plus that value of x. Okay, 3 plus that value of x. So basically if I want to calculate, okay, if I want to calculate the effect, okay, the final answer, the expectation also, okay, the expectation will also be related. That is what is happening. Okay, similarly if I do this, if I do comparison between these two variables, there is a random variable x and there is a random variable a, and how I have created this a, 4 into x. Whatever is the value of x, multiplied by 4 and I'll get this new random variable. Okay, now when I calculate the average, okay, calculate the average. What is this average? 1108. It is basically calculated. Okay, now can I use this logic basically? So can I calculate the expectation of, what was the number? The number was 4 into x, right? So 4x, this is a new variable, right? What was the answer? 1108. Okay. Now can I get the same answer by multiplying 4 to expectation of x? And when I start doing it, I'll be able to find it, right? So it is nothing but 4 into the expectation of x. So I get 1108, which is matching. So both the numbers are matching, correct? So we can apply this logic. Similarly we have x and this z. What is this? 3 plus x. So can I do it like this? So I am taking expectation of 3 plus x, which is actually equal to 3 plus expectation of x. So what is my expectation of x? If I go to this Excel sheet, that is 277 I have calculated. Okay. So what I can do is, that is 277 plus 3. So the answer should be around 280. So when I go and calculate, it is 280 only. You can check this. Right. So I hope everybody is in sync. So when I talk about the formula, okay, so over here the C was constant. Some constant is getting multiplied. Okay, if I want to find this new variable z, which is some 3 into x, if I want to find the average of that, it is nothing but take 3 and multiply it to the average of that original random variable. Okay, similarly over here, if I have two random variables x and y, okay, and I have created a new variable which is a combination of x and y. So there is an example also over here. One second, I have not created an example as such, but I can create, say, x and y, and I can create a new random variable from that x and y. Suppose that random variable is e, okay, which is a combination of this. I can take the average of x and I can take the average of y. I can add, and I'll be able to find that it is exactly matching with the expectation of that new variable. That is a concept that you need to be clear. So I am marking this section as star for this exam explicitly, because I've never heard that in the last two exams they have asked you. So I'm expecting that they might test you on this. Okay. Mean, variance and kurtosis. Now, a lot of students have this fear that, okay, I'll have to calculate this. No, you need to be clear on the formulas. Okay, what is the formula? What are they doing? They will not ask you to calculate. Okay, so when we talk about variance, how do you calculate the variance? Variance of x. So the first formula is very simple: x minus x bar, the average, to the square of it, and then take the expectation. Very, very simple. Second formula is expectation of x square minus expectation of x whole square. Okay. So basically both the formulas are important. Paras, answering to your query, both the formulas are important for variance. Okay, you should be clear. There are not many formulas, it's only two formulas. Okay, there are not many formulas. So this is the first formula. The way I had written is this: expectation of x square, and do the x minus x square, x bar, take a square, and then do the expectation. That is the formula. Okay. So broadly, you should know what is variance, what is it doing. It is basically telling you how much deviation you have from the average. Okay, but the variance is in the square term. So if my original data is in centimeter, then the variance is going to be centimeter square. So I need to remove that square part. So I'll take a square root of it, and I will be able to reach a standard deviation. That is the core logic. Okay, I hope everybody is with me. Now, what is the skewness? See, skewness is nothing but the third central moment, which is nothing but this: x minus bar raised to 3. Okay, now how do we get this logic? So what is the first central moment? Central moment means how far you are from the average. So first central moment is going to be x minus x bar raised to 1. This is the first central moment. Okay, first central moment. If somebody asks me, calculate the second central moment, which is going to be this second central moment, do you realize this is nothing but your variance? Okay. If somebody asks me calculate the third central moment, then this third central moment will help you, okay, to find the skewness. But what is the problem? This third central moment is not easy to interpret. So what we will do, we will take this third central moment and we will do standardization. Sigma cube. If you remember, in normal distribution also we divide by sigma to standardize. Okay, but over here, why are we doing it raised to 3? Because the numerator is also in the format of 3. So we'll have to do it in that way. Okay, and this entire thing is the skewness. What skewness actually tells you? So the concept of skewness is very important for your entire FRM level and level 2. Skewness basically tells you whether the data, if you look at this data, this is my average. Okay, if the data is skewed, okay, if the data is skewed, okay, then you have the tail and the tail, there are a lot of data away from the tail. There is some probability available to it. So it squeeze into that core area, the tail area, and because of which what happens, your mean gets impacted, your mode gets impacted, so your calculation changes. Okay. Paras, answering to your query, why we are not dividing by n minus 1. Okay, when you have all the probabilities equal, then you can do this formula of the variance, which is nothing but summation of x minus x bar whole square, and you divide by n when it is a variance of the population. If it is sample, then you divide by n minus 1. When I'm doing expectation, I'm saying the weightages are different. In this case, the weightage is same. Okay, I hope everybody is good. So skewness, you should, for the exam, there is no need for you to calculate the skewness. What is important is that you should know what is the skewness talking about. Okay, what is the broader structure of the formula. Okay, same goes to the kurtosis. Basically, kurtosis tells you the shape. So skewness, you can see these examples. This is positively skewed. Okay, this is negatively skewed. So far away from the average. Okay, far away from the average. Nikhil, answering to your query, yes, if when we are calculating variance, okay, we are dividing by n minus 1. If the probability for all the values is equal, then only we can divide by n or n minus 1. No? If the probability is different, then you are doing expectation E, because then each outcome that you are getting, x minus x bar square, you are multiplying it to the probabilities. Okay. Let us move towards the kurtosis. So again, kurtosis is the fourth central moment. So because the numerator is raised to 4, you are doing standardization in the form of sigma raised to 4. What does kurtosis tells you? Whether you have fat-tailed data or not. Okay, so if you look at this example, mark this diagram as star. They can ask you some theoretical question related to what is happening in the diagram. Okay, so when you look at this, this blue diagram is a normal distribution, and there is a high kurtosis data. When you look at the high kurtosis data, it has fat tails on both the sides, which means you have more data outside the range or far away from the average. Okay, so if you look at, this is my average, so there is more data over here, okay, and more data close to the average. So more data close to the average, more data far away from the average. That concept should be clear in your mind. PDF function, so it is nothing but trying to find the probability of a continuous variable, very, very basic. Quantiles have been tested. Okay, the concept of quantiles have been tested, which is nothing but when you look at CDF, cumulative density function. Okay, it basically helps you to identify that if the value of a random variable takes x, y, z, what is the probability till that point. So I'll take an example of discrete random variable. So suppose you are throwing a die, okay, and you have random variable 1, 2, 3. Outcome is this. Now, when you're trying to find a cumulative value, okay, of say f getting a 3, so what you'll do, you'll start from here, you'll add the individual probability of all of them till 3. So what is the probability of 1? 1 by 6, 1 by 6, 1 by 6. So my answer is going to be 3 by 6, right? If I'm saying f of 5, that means I'll have to start from here and continue till this point. So 1 by 6, 1 by 6, 1 by 6, like that. So cumulative is very important, okay, as a concept. Okay, what is happening over there, and quantile function, okay, where it is an inverse of cumulative density function. How come? Because when we talk about cumulative, it is like this. Look at this diagram. So for example, if this is the cumulative distribution, how does it help you? So if suppose I have a value over here, I can use this diagram to find, oh, what is the cumulative probability. The same way we got this cumulative probability for a particular value. Okay, but when we talk about quantile, what we are simply doing is we are doing exactly inverse. That means I know what is the probability. I'm going to use this diagram to come to this value. So it's exactly inverse. So the concept of quantile should be clear to you. Okay, concept of quantile should be clear to you, that okay, you have a particular probability, so you're going to go back to the average or go back to that value. So quantile of 74, for example, gives you the value of 122. So they have given you an example also. But what is this quantile function? How it is connected to CDF? That you should know. Okay, interquantile range is also important. So remember, from the perspective of questions. Okay, so interquartile range has been tested in the exam. So if you want to understand interquartile range, you have to look at the box spread, box and whisker spread data. Okay, so you have to visualize it in this way. This is the lowest value. Okay, that means 0% is the starting point. Okay, till this point we reach 25%. Then there is this which is 50%, and then there is this which is 75%, and then there is 100%. Okay, let us look. This is from the percentage perspective. If I want to convert this into some actual data, suppose I have tried to calculate the age of people who have died in the last 1 year. Okay, so let us assume the youngest person who died is 27. Okay, and I'm just randomly putting values. So this is the maximum age of somebody who has died, and this is the minimum age. Now, what does this first bucket highlights me? First bucket tells me that 25% of people who died are between 27 and 35. The next 25%, okay, are between 35 and 40. The next 25% is between 40 and 49, and the final 25% is between the 49 to 60. If somebody asks me, okay, that, okay, what is the interquartile range? I'm talking about the middle 50%. Okay, so that means the middle 50% range from 35 to 49%. Okay, so that is what you should remember broadly. So mark this section as star, interquartile range. Linear transformation, even though it seems tough, okay, it is actually not very tough. You just need to look at the Excel sheet to understand it much better. Okay, but generally this is not tested in the exam. Okay, so not very important as such, because you need to see some examples, and if you remember, I have also shown you in my class the Excel sheet, and through which we try to understand what is the concept. So we are moving towards the next section. Is everybody okay till this point? सब लोग हैं मेरे साथ में? Common, univariate, random variable. Everybody, can I get a quick confirmation on chat? Okay, let us move to common, univariate, random variable. This chapter is important, okay, from the exam perspective, so do not skip this chapter. There are very specific sections which can get tested. Again, historically, some part I have not heard more being tested. I'll highlight that also. So first is uniform distribution. Now, if they ask you explicitly in the exam, so they might ask you this type of question. Very good chance of this question being asked. You can look at this diagram, that there is a random variable x which is uniformly distributed between 2 and 12. Okay, so entire area is between 2 and 12. Somebody, that means 100% area is between 2 and 12. If somebody is asking what is the area between 4 and 8, so you just have to cut this area. Okay, cut this area. So how will you find? So the entire area is between 2 and 12. So what is the total area? That is 12 minus 2. And what is the area that we are looking at? 4 and 8. So it's going to be 8 minus 4, and then you will be able to find the answer. Basically, you have to think it like this. I have a cake in front of me. This part is taken by my friend. How much percentage has been eaten by my friend? That is what I am trying to find. Okay. So most likely they can ask you this example. Okay. Very new thing. They have not been testing this in the previous section. Broadly, you should also, this is the same formula that we just talked about. Next, cumulative, they will not test you more likely. Bernoulli. Okay, so the basic formula for Bernoulli, this was also there in one of the previous chapter. So that is effectively there, the basic formula of Bernoulli, and the variance of Bernoulli, average of Bernoulli. These three things you should remember. Okay, over here generally it is n into p into q, variance. Okay, but n is considered as 1 because Bernoulli talks about only one event. Hence the n is 1, so it is not shown over here. Okay. Binomial distribution, very important. Mark this as star. This entire formula, okay, NCX, is testable in the exam. That means this entire formula is testable. They have been testing in the history. Okay, so very important section. Do not leave that. Over here, if they have a direct formula in the Excel also. Okay, I'm not sure if it is right above the plus button or multiplication button. The NCX formula, you can check that in your calculator. You can directly implement it. Okay, so if suppose it is in the second button, multiplication button. So what will you do?